Knowing the fundamental theorem of algebra, we're able to use the degree of the function to determine how many possible zeros, or x-intercepts is another word. So the degree of the function tells me how many possible times it could cross the x-axis, this curve. So given f of x here, the degree is the largest exponent. So we know that there are 3 possible zeros. The shape is also determined from the degree of the function because shape is based on whether or not we have an even or an odd shape, an even or an odd degree. An even degree tells me that the ends of the curve will point in the same direction, whereas an odd degree tells me the ends will point in different directions, whether one side up and the other side down. Now, which direction that is, that comes from the leading coefficient. So based on the leading coefficient, if the leading coefficient is positive, so we can also say A, if A is greater than 0, then we know that when we're graphing, the right side will point up. And if it's even, the left will do the same thing. But if it's odd, the left would do the opposite. If the leading coefficient, the A value, is a negative number, less than 0, then that tells me that the right side of the graph is going to go down. And the left side, again, will be based on if it's even, the degree, then even degree would go in the same direction. So that would be something like negative x to the 4th, but an odd degree would go in opposite directions, like negative x cubed. To find the x-intercepts, we could start with the rational root theorem. The rational root theorem tells me to take the factors of p divided by q, which is basically the constant and the leading coefficient. So I'm going to use factors of p and q. That would be negative 210, listing all of the factors divided by all of the factors of 1. So we've got 1 and 210, 2 and 105, 3 and negative and 70. And then we've got five and 42, 6 and 35, 7 and 30, 10, 21. Once we have our list of factors, that's what's going to give us options for being able to substitute and use synthetic division. So if we have a list of factors, we can then use synthetic division. To complete synthetic division, we're going to drop down the coefficients 1, negative 18, 107, negative 210, and then we're going to use plus or minus any one of those factors that we came up with when we did the factors of the constant divided by the factors of the leading coefficient. So if I just pick 5 and use that in my synthetic division, I'm going to drop down my 1, multiply, add, multiply, add, multiply, add. Because I got a remainder of 0, I know that 5 is a factor. So 5 is one of my x-intercepts, 5, 0. Now that I know the synthetic division works there, I can use what's left. One, -3, and -14. I can, or 1, -13, and 42. I can use that to write my depressed equation. So we have 5 as one of our factors, which means if it's a positive 5 is the x-intercept, then that tells me that came from x minus 5 as a factor. And then we're left with 1x squared minus 13x plus 42, which is a quadratic equation that we can factor by saying what two numbers multiply to give c and add to give b. Ax squared plus bx plus c. C is 42, b is -13. A negative times a negative is a positive. So I'm looking for what two numbers have a product of 42 and a sum of -13. So -7 and -6. Multiply to give me 42, but add to give me -13. So that allows me to factor it. Now that I have it in factored form, I can set that equal to 0. Setting each factor equal to 0 allows me to find all of the x-intercepts. So 5, 0, 7, 0, and 6, 0 is where it crosses the x-axis. So just from the degree and the leading coefficient, we know shape, direction. Now we know where it crosses the x-axis. That's enough information to sketch the graph by hand.